The second topic that we talked about last Wednesday was how to solve an equation that has a square root in it. Right? So in other words, how to undo a square root as part of the process of trying to get the variable by itself and solve an equation. And the guiding principle here is that the whole purpose of a radical is to undo a power, and therefore the purpose of a power is to undo a radical. Right? Those two are inverse to one another. So any equation that has a radical in it, like this equation here, square root of x is equal to 7, we can get rid of that radical by raising both sides of this equation to a power. And in the case of the square root, whose job is to undo an exponent of 2, 2 is exactly the exponent we need to undo it. So raising both sides of this equation to the second power is how we get rid of that radical and get the x by itself. And in the case of this equation, that was really just a one-step process. Right? As soon as I just have a square root on one side, taking the square is just going to get rid of it, and in this case, just gave me the x by itself. In this more complicated example, on the right-hand side, the principle was the same, but there was a lot more algebra wrapped around it. Right? If 1 plus the square root of x plus 3 is equal to 3x, then before I square both sides, I want to make it so that that square root, that radical quantity, is already by itself. Otherwise, I would have to multiply out this left-hand side of the equation in a grid. We'd get a bunch of extra terms. A couple different terms would have square roots in them, and then things would be even more complicated. So we want to get that radical isolated first before we square both sides. So here that just meant subtracting 1 from left and right. And then, because the square root was by itself, we can square both sides and get rid of the square root. But the degree of difficulty that that introduced is that now on the right-hand side we had 3x minus 1, the quantity squared, which we had to multiply out as a binomial. We had 9x squared minus 6x plus 1 on the right, x plus 3 over on the left. And that's not the easiest equation in the world to solve, but we have the tools to do it. We would do that by getting a 0 on one side, which is the most important first step in solving any quadratic equation. One side of the equation has got to be 0, whether we're going to factor or whether we're going to use a quadratic equation. That's always important. When I did that, I ended up with 9x squared minus 7x minus 2 on the other side. And then, just to get some more practice with our factoring techniques, we decided to try to use factoring to solve that quadratic. Now, we could have jumped straight and used the quadratic formula, but just to get the tie back to factoring, we used the AC method on this. So we looked for a pair of numbers which multiply together to give me a times c, 9 times negative 2, that's negative 18. And that same pair of numbers needed also to multiply together to give me negative 7. And so the pair of numbers which met that requirement was negative 9 and positive 2. So we used negative 9 and positive 2 to split the middle term, and then factor this polynomial as 9x plus 2 times the quantity x minus 1. And then comes the step in the solving process that about a third of you or so forget when these problems come up on quizzes. You're not alone. A lot of people forget this when it comes up, because you take a victory lap after you factor, and you forget that there's still work to do. And the work that you still have to do is take this equation, and now it's been factored on one side and there's a 0 on the other, you can split it apart into two simpler equations, and then solve each of those simpler equations to get our x values. So x equals negative 2/9, x equals 1. So everything from here forward we knew how to do before Wednesday. The important thing for Wednesday was, how do we get rid of that square root sign? And as soon as that square root is isolated on one side of the equation, squaring both sides is your strategy to get rid of it. Because once it's gone, then hopefully everything is just in terms of polynomials, and we have tools from the 4 weeks that we spent working on polynomial algebra to solve equations that have polynomials. These solve many equations that have polynomials in them.